We consider aspects of reconfiguring a set of objects with the help of external forces, such as a magnetic field or gravity. This concept can be used for a wide range of applications in which particles do not have their own energy supply. If we apply a global input on two particles, they move until they hit a wall. If the wall has low friction, they may slide along the wall. For any material, there is a range of angles for which the particle will not slide. The maximum angle theta we call the angle of friction. Next, we illustrate the delta configuration space. Place one tiny red particle in the corner of the workspace. The blue particle can obviously be placed anywhere in the workspace. Now use the red particle as a reference and move the workspace so that the red particle is in the right corner. Again, the blue particle can be placed anywhere inside the translated workspace. Continuing this, we see that the delta configuration space is a hexagon. The paper introduces 5 motion strategies for reaching configurations in the delta configuration space. Each has a different color. If theta is small, not all the delta configuration space is reachable. If the angle of friction theta is large, the strategies overlap. The blue strategy holds R1 and moves R2. The red and green first place R2 in a corner and move R1 to an opposite corner. The violet and orange strategies use different sets of corners.
These techniques can be adapted for multiple particles. Our paper proves that not every reconfiguration of 3 particles is possible. On the positive side, we show that we can perform arbitrary permutations for a line of n particles. The video on the right is taken from a camera mounted on a bucket. When the robot moves the bucket, the particles slide until they hit the boundary, which is coated with 220 grit sandpaper. The workspace is 115 by 115 millimeters, and the particles are 9 millimeter squares.